Okay, before we get started, I want to remind you what an inverse actually is. See, this has to do with, this is called matrix inverse. So I want to review what an inverse is in the first place. So right up here at the top, let's talk about what an inverse is. So first of all, let's talk about a multiply inverse. Okay, a multiplicative inverse it's a number that always forces multiplication problems back to 1. The inverse number for multiply is the number 1. So let's just say let's say we start out with something like 7, and we have to multiply that by something that always goes back to 1. So that has to be 1/7 in this case. So 7 and 1/7 are multiplicative inverses. If I start out with -3, well then I need -1/3 to make that go back to 1. So an inverse in multiplication is always trying to force it back to 1. So it can be negative, it can be positive. If I start out with the fraction 2/5, then the multiplicative inverse of that is -5/2 because it forces it to 1. So that's what a multiplication inverse is. And I would like you to I left some space on your paper up there and put this in that space. So if you haven't written this part down, hit pause and write this part down. I want you to have an example of what a multiplication inverse is. Now I don't have quite enough space because I'm writing kind of big for the video, so I'm going to erase this part and do the next part. So put this part up here in that space also. The other thing I want us to deal with is what is an additive inverse. Those force everything to 0. So multiplication inverses force things to +1. Additive inverses force things to 0. So now if we have that 7 like we did before, we need to add something to it so that it's equal to 0. So -7 is the additive inverse. So 7 has a multiplicative inverse of 1/7 and an additive inverse of -7. And now if I have -3, I have to add something to that to 0, so it would be +3. And if we start out with 2/5, I have to add something to that to make it 0, so it would be -2/5. So additive inverses are different than multiplicative inverses because additive inverses are trying to make it go to 0. Okay, and then the last part, now this part you really need to have up there because we're going to refer it. So in this section of your paper up here, in this section of your paper, I want you to make sure you have this last piece. We need a matrix inverse. And a matrix inverse forces whatever matrix you had to go to the diagonal of 1s. So if it's a 2x2, it'll look like that. If it's a 3x3, it'll look like this. See, a matrix inverse is forcing that diagonal right there to be 1. And a matrix inverse is, so if this is matrix A, let's say we have matrix A and it's 1, 2, 5, -4, something like that. Okay. The inverse is written like this. It's A with a -1 power in it. And that's going to be some matrix so that when we multiply those together, it ends up being 1, 0, 0, 1. And that's going to be our task, is to be able to find this. So we do this times this ends up being this is called the identity matrix. Okay. So it's called the identity matrix in it. So this is often written like this. I haven't shown you how to get the identity matrix yet. That's coming next. So the symbolism for that is matrix A times matrix inverse is equal to the identity matrix. So that's just usually abbreviated with a capital I. And that identity matrix is this thing. Okay. how do we get the identity matrix? How do we get the inverse? So I'm just going to show you the definition. And there's a big, long proof in a college algebra course to get this, but in high school, we don't need to know the proof. We just need to know how to get it. Okay, so to get the matrix, to get the inverse matrix, we take 1 over the determinant times the matrix. Now remember, these matrices, we have to all agree that that's the A spot, the B spot, the C, and the D spot. So that's what a regular matrix usually looks like. Okay, so to get the inverse, we do 1 over the determinant. That's how come we practiced the determinant in the last section. It's 1 over the determinant times. Now we're just going to manipulate these. See how the A and D are in those two spots? The first thing we do is exchange those two. So the D number is now going to go there, and the A number is going to go there. So whatever was right here now goes in that spot, and whatever was right here now goes in that spot. And then we're going to negate the C. So whatever the C number is, it's now negative, and whatever the B number is, it's now negative. This you need to know. This put in a box like I'm doing, because we're going to refer to that when we do the homework or some of these problems. Okay, let's take a look at one of these and see if we can't figure out how to do some of that. So let me take a look at number 1. Okay, so here's what I need. Here's the identity matrix. So notice this part right there, that's the determinant. We got to remember what actually the determinant is from last time. So the determinant from the last time was the A number times the D number minus the B number times the C number. Okay, so let's see if we can apply that then. Okay, so right here, let's get the determinant first. The determinant of this matrix. Remember, it was like absolute value signs. The determinant of this matrix is the A number, so that's the 0 times the D number, so 0 times 4. Minus, and now we need the B number, so that'll be the 12, times the C number, the negative 8. Okay, so here we have 0 minus negative 96. So the determinant of this is 96. Okay, so now let's take a look at our formula here. We have 1 over the determinant. Okay, so the matrix of this is going to be 1 over 96 times. Okay, so now I need the D number in the first spot. So this is the D number. It's going to go up there. So the 0 and the 4 are going to switch positions. So the 4 goes there, and the 0 goes there. And then the B and the B and the C get negated. So that's going to make, that's the 12 now is negative 12, and the negative 8 is positive 8. Okay, well, let's see. I'm going to go ahead and multiply those things together. So now we have scalar multiplication. So this is going to end up being 4 over 96. Okay, so 4 over 96 can reduce to 2 over, what, 40 something? 96 cut in half is 45, or is it 48? So I guess I can cut that in half again, so it'll be 1 over 24. And then I have 12 times 96, or I mean 12 divided by 96. I'll do the, is 1, so let's see here, what do I have? Negative 12 out of 96. But that will reduce to 1 over 8. And this one right here, I'm going to have 8 over 96. Oh, let me reduce that. 8 over 96. is 1/12. And then 0 over 96 is still 0. That is the inverse matrix. Okay, now I want to prove that. So what I want to do now is take this, the original matrix, times this, the inverse matrix, and it better give us the identity matrix or something is wrong. So let's do that. So let's take 0, 12, negative 8, 4, multiply that times 1 over 24, 1 over 12, negative 1 over 8, and 0, and see what happens. Okay, well this is going to be a straightforward 2 by 2, so I know I'm going to get a 2 by 2, and remember we go this times this. Let me open this up a little bit. Okay, so it's going to be the first one times the first one, so 0 times 1/24, that's just going to be 0, plus the second one times the second one, so it's going to be 12 times 1/12. Okay, how handy is that? 0 plus 1, that's easy. Okay, this one over here, it's going to be these times these. Okay, so I got 0 times 1/8, that's 0, plus 12 times 0, that's 0. Okay, now I'm going to go these times these. Okay, negative 8 times 1/24. Plus 4 times 1/12. Okay, let's see here. If I take this fraction right here and double it, we'll have a common denominator. So if I double it, that will be 8 and that will be 24. So I have negative 8/24 plus positive 8/24. And then the last one, I'll take this times this. So it's going to be negative 8 times negative 1/8. Negative 8 times negative 1/8, let's see, will be 1. And then 4 times 0 is 0. Okay, look what we ended up with here. If I simplify all of that thing, okay, there's a 1, 0 plus 0 is 0, negative 8/24 plus positive 8/24, and 1 plus 0. Sure enough, the original matrix right here times our inverse matrix ended up giving us the identity. And that's what it's supposed to do. Okay, let's do that with another one. Let's come over here and do number 2. Okay, so I need 1 over the determinant times, right here it is again up here, so I need the D number up there. So the D number will be negative 3, then I need negative B, so I need negative this one, and then I need negative this one, so that will be positive 3, and then the negative 4 switched around. So those two switched places, and those two changed signs. And all I really need is the determinant of that. So to get the determinant, is, it's right here again, AD minus BC. So I need A, D, minus B, C. So the determinant is 12 minus negative 3. So the determinant is 12 plus 3 for 15. Okay, so you can answer this. Sometimes they have the 15 factored in and sometimes they don't. I'm okay if you answer that as 1 over 15 times negative 3, negative 1, 3, and negative 4. You can answer it like that. That is the determinant. A lot of times, if you were doing this on a computer, they would multiply in the 1/15. So negative 3/15, negative 1/15, 3/15, and negative 4/15. And then by reducing the fractions. So we have -1/5, -1/15, +1/5, and -4/15. So you can answer it like this also, but you can leave the 1/15 factored out if you want to. Okay, so hopefully that starts to make it feel just a little bit easier. All right, let's do number 3. I don't think it'll take that much space now. So the determinant, I need the determinant of A. So it's going to be AD, so that's 4 times 6 minus BC, so -4 times -6. So I've got 24. Here I've got 3 negatives, minus 24, so that's 0. So it's going to be 0 times it doesn't even care. We don't even care what that one is. So this one does not have this one does not have an inverse. And that's how you answer that. There is no inverse. So not all matrices have an inverse. So this is non-invertible, and that makes a big deal in another topic that we're going to deal with later. So if something does not have an inverse, then there are issues. Okay, let's come over here to question 4. Number 4, I'm going to need a lot more space, so let me grab it here and see if I can get us another piece of paper. Get to number 6. All right, let's get the determinant of this one. So the determinant is going to be -5, and then here's its mini determinant. So it's going to be the -5 times the 5 minus the -5 times the 2. So there's that one. Now I'm going to okay, I got to remember to do the checkerboard. So this is a positive, a minus, and a positive. So then I'm going to subtract the -4. And now get rid of that. It's going to be the 5 times 5 is 25 minus -1 times 2 plus, and let me erase a bunch of this stuff so I can see it. Okay, plus the 4, and then here's its mini matrix. So it'll be 5 times -5 minus -1 times -5. So altogether I have here -25 plus 10, so -15. So -5 times, -5 times -15 would be 75. Here I've got 23 times 4 is 92. So then I've got 2 negatives, so it'll be plus 92. And then here I've got -30 times 4. So -30 times 4 will be plus -120. Add all that up, it's 47. So the determinant of this matrix is 47. Okay, that's just the beginning. So now we've got to get this thing called the adjugate. Okay, so step 1 is to get the determinant. Okay, now I've got to get this thing called a cofactor matrix. Okay, let me erase all of this so I can have a fresh start. So to get the cofactor matrix, what we need is a matrix of the minors. Okay, so this is going to be called, I'm going to call this a matrix of the minors. Okay, what I need is I'm gonna end up with a 3 by 3 matrix. Okay, and what I need is the determinant of all of the spots. So what I mean by that is I'm going to take this one out. So if I take a look at that spot and get rid of the row and column, I need the determinant of what's left. So that would be the -5, 2, -5, 5. Then I'm going to move on to the next one with the -4, get rid of those. That's going to leave me with 5, 2, -1, and 5. Then I'm going to get rid of that one and get the minor for this one. So getting rid of those two leaves me with 5, -5, -1, and -5. Okay, getting rid of that one. The next one I'm going to do is this one. So now look at what we're going to get rid of. It's row and it's column. So this one right here is -4, 4, -5, 5. That's these two. Okay, and then just keep doing this process. I'm going to do the -5. That's going to get rid of this one and this one, leaving -5, 4, -1, 5. I'm going to go for the 2. That's this row and this column. That leaves -5, -4, -1, and -5. Okay, coming down the home stretch, we'll get rid of this one. That's that one and that one. Okay, that leaves -4, 4, -5, 2. Okay, now I'm on to this one. That gets rid of that row and column. Leaves -5, 4, 5, and 2. And then the last one is this 5. We'll get rid of that one and that one for a total now of -5, -4, 5, and -5. Okay, I need that matrix. So I need to find the determinants of that matrix, and that's going to leave me this nice 3 by 3 matrix over here. Okay, I'm going to do most of this in my head. Remember, it's these two minus these two. So -5 times 5 is -5, and that's minus -10. I mean -25 minus -10, so -25 plus 10 will be -15. There's 10 minus -2. 10 minus -2 is 12. Now, I'm really trying not to make a silly error, but if I do, apologize. Just ignore it. So that's going to be -25 minus +5, -25 minus 5. -25 minus 5 will be -30. Okay. Here I have -20 minus -20, so -20 plus 20 will be 0. -25 minus -4, so it'll be -25 plus 4, so -21. -25 minus 5. So it's 25 minus 5 will be 20. There's -8 minus -20. So -8 plus 20, 12. -10 minus 20. -10 minus 20, so -30. And there's 25 minus -20. So 25 plus 20 is 45. Okay, going back over that here quickly in my head, I think I have this one wrong. There's 25 minus -2. So 25 plus 2 should make that one a 27. Let me fix that. And how about this one? Doesn't look right. That was 25 minus 4. 25 minus 4 should be 21, not 20. Okay, I think that's correct now. Now here's what the adjugate is. You got to take the matrix of minors, and we're going to turn that into the adjugate. Okay, the adjugate takes this row and it makes it the first column, and then it's going to take the second row and make it the second column, and then it's going to take the third row and make it the third column. So let's see if I can't make it do all of that. Okay, so right here it is. So I need the negative 15, 27, negative 30. So negative 15, 27, negative 30. Now I'm going to take these and put them over here. So I've got the 0 and then the negative 21 and the positive 21. Now I'm going to take the blue one. So I've got the 12, the negative 30, and the 45. That's the adjugate. You get the matrix of minors, and then you switch row to column. So back at the beginning, so really how we get the inverse of a 3 by 3 is we take the determinant times the adjugate of that same matrix. Okay, so we got the adjugate and we have the determinant. We have it done. The determinant was, should be 1 over the determinant. So the determinant was 47. So we multiply all that by 1 over 47. Okay, I have one more thing because that doesn't feel right, and I think it's all the way back up here. Probably some of you are watching this video and found an error way back up at the beginning. It's right here. That's not right. That was 25 minus 2 with the negative 4. So that was 5 times 5. That's the 25 minus 2 times 1. It should be minus 2 times 1, which makes that a 27. So 4 times 27 is 108. That piece right there is 108, which makes this piece was really, that 47 right there was really a 63. So this piece down here is 63. Okay, now I'm sure that's right. I went to check that in. What I actually did was I took this times this, and I got 111000000. I got the identity matrix, so I'm now sure that is right. Okay, let's do that. Let's do another one. Okay, so that was number 5. Okay, so if I call this one matrix A, we need the inverse of A. So the inverse of A here is going to be, the inverse of A is written like that. It's going to be the determinant of A, so that's going to be a hassle. But then it's multiplied by the what's called the adjugate of the matrix. Here's how that's spelled. Of A. Okay, so on the smaller ones it was easy. We just switched around A and B. We just switched around A and B, and then we negated those two. But it's more difficult when you have a 3 by 3, and I'll show you what the adjugate is here after we find the inverse. So first things first, let's find the inverse of this thing. So now remember, the inverse of A, not the inverse, the determinant of A is we're going to take this, the number. So first of all, we got to remember we're going to do a positive and then a negative and then a positive, kind of a checkerboard pattern of that. So we're going to take this 6 and then get rid of its row and column and find the determinant of what's left, 0, 0, 0, negative 3. Okay, then we're going to do a subtract, so minus. And then I'm going to take I'll do a change of color right here. Now I'm going to take the 1 and get rid of its row and column. So it's going to be a 1 minus a 1, and then the row and column is going to be 0, 0, 1, negative 3. And then lastly, plus, so the third one is a plus. I'll take this 3, was that a 3 right there? Yes, that's a 3. So I want to take the 3 and then get rid of its row and column, and what's left is 0, 0, 1, 0. Okay, let's see if we can't come up with what this is. So we've got 6 times, okay, so it's these two minus those two. So 0 times negative 3 minus 0 times 0. Okay, then for the blue, then it will be minus 1, and then 0 times negative 3 minus 0 times 1 plus, and we have a 3, and it will be 0 times 0 minus 0 times 1. Okay, this is looking not very difficult now. So we've got 6 times 0 minus 0 is 0. Then I've got minus 1 times 0 minus 1. Oh no, that's a 0 times 1, so that's going to be 0. And then I've got plus 3 times 0 minus 0. Okay, so that's all going to add up to 0. So the inverse is 0. So this one is not a very good first example. Why did they put this one first? So this one has no inverse. It's going to have a determinant of 0. So 0 times the adjunct isn't going to matter. So this one has no inverse. Okay, I guess it was kind of good to remind ourselves how to get the inverse of it, the determinant of it. Okay, so these want us to find the inverse, simply the inverses. So we got a couple 2x2s and a couple 3x3s. All right, the 2x2s are reasonably straightforward. So all we have to do is get the determinant. So it's 1 over the determinant of A times, switch around these two corners. So I'll put the 10 and the 11 will switch around, and then the 7 and the 0 will change signs. So I need a negative on that one and a negative on that one. So that's our strategy. So get the determinant first. Okay, so the determinant of A is simply negative 11 times 10 minus 0 times negative 7. Okay, so that's negative 11 times 10 is negative 110 minus 0. So there's the determinant. Okay, so it's going to be 1 over negative 110 times the matrix. Okay, switch these two around, so I'll switch those two around, so that's going to be 10 and negative 11, and then negate the other one. So when I take 0 and make it negative, it's still 0, but when I take the 7 and make it negative, it's going to become positive 7. And you do not have to multiply in the 101 over 110. So doing 2x2s, pretty straightforward. Number 7, the determinant. Okay, negative 5 times negative 10 minus 11 times negative 5. So I've got 50 minus negative 55, so 105. So it's going to be 1 over 105 times the matrix. Switch these two, so negative 10 and negative 5, and then negate those two. So negative 11 and positive 5. Okay, so more of those. So go ahead and pause and do number 8 and see if you have it correct. The determinant of A is -2 times 10 minus 3 times -3. So I've got -20 plus 9, so -11. So we have 1 over -11 times the matrix. 10 and -2 switch places, and then that 3 changes signs, and that 3 changes signs. So 2 by 2s are very fast. Of course, it's the 3 by 3s that are not very fast. So let's see if we can get this number 9. I'll try not to make I'll try not to make the error this time. So for the determinant, I need plus, minus, plus. The determinant's the easy part. Okay, so I need -4 times the determinant of what's left. That's the 4, -4, 2, 4. Minus, I need the -2 times its determinant, which will be 0, -3, -4, and 4. So that's taking this one. Now I'll take this one, so plus -3 times its mini matrix of 0, 4, -3, and 2. Alrighty. So we have this one right here, -4 times 16 minus -8. Here I've got a minus minus, so that will be plus 2. And then it will be 0 times 4, so that will be 0 minus -3 times 4. And then here I've got plus a -3, so minus 3 times 0 times 2 minus 4 times -3. So 16, up here at the top, 16 plus 8 will be 24. So I've got -4 times 24 plus 2 times -12 minus 3 times 12. Excuse me, so I've got -96 minus 24 minus 36. So we got -156. Okay, there's the determinant. Now let's go back and start over. Okay, so now I need the matrix of mini matrices. The matrix of the minors. Okay, so when I do the -4, its minor is going to be 4, -4, 2, 4. Now I'll do the -2. Its minor is 0, -4, -3, and 4. And then I'll do the -3, so its minor's right there. 0, 4, -3, and 2. Okay, now I'm gonna take this one. So its minor is -2, -3, 2, 4. Now I'll do this one. So its minor is -4, -3, -3, 4. And now I'll do this one. So its minor is -4, -2, -3, and 2. And now I need this one. So its minor is -2, -3, 4, -4. This one right here. So that has a minor of -4, -3, 0, and -4. And then lastly, this one is -4, -2, 0, 4. Okay, so we need a matrix of those. Pretty much on the home front now here. All I got to do is not multiply these wrong. So there I have 16 minus -8. So 16 plus 8 will be 24. Here I have 0 minus 12. Here I have 0 minus -12. Here we have -8 minus -6. So -8 plus 6. -16 minus 9. -16 minus 9. -17. No. -16 minus 9. -7. Here I've got -8 minus 6. Here's +8 minus -12, so 8 plus 12. 16 minus 0. Here's -16 minus 0. And now I need to take this row, bring it down, this row, bring it down, this row, bring it down. So the yellow row, 24. Whoops. Okay, all I want is a black pen. Okay, so 24, 12, that was a -12, and 12. The green one was -2, -7, -2, and the blue one, 20, 16, -16. Times the 1 over the determinant. Okay, here we go, number 10. I put it on a blank piece of paper so we can have it all to ourselves. Of course, it would be, you could push pause on the video and see if you can get it right yourself. But of course, I will do it also. So here comes the determinant. So the determinant of A is going to be 4. I need the positive, the negative, and the positive. So it's going to be 4 times 4052 minus 1, that's this one, times 4022 plus this one, -2 times 4425. Okie doke, so we have 4 times these two is 8 minus 0. Minus 1 times there's 8 minus 0. Plus -2 times there's 20 minus 8. So we've got 32 minus 8 minus 24. Well, looky there, that equals 0. This one has no inverse. That's a nice way to stop.